Here is another question from homework number 11. It says find the probability of winning a lottery with the following rule. Select the 6 winning numbers from a set of 1 through 26 in any order, no repeats. All right, so first of all, this question is find the probability. Find the probability. So right there, we put this right at the top of our page. The probability of any event is the number of successes, ways we get what we want, over the total possible outcomes. I'm writing a modified version here because I write it so many times. All right, so let me ask you this. In this case, the numerator is quite easy to find. How many successes are there? How many winning lottery numbers are there? There is only one. All right, over. Well, here comes the hard part. Out of a total possible outcomes. In other words, how many possible ways, how many different ways can you arrange 6 numbers out of a set of 26 or choose 6 numbers out of a set of 26? What are all your possible lottery number choices? You got a big number down here, and this is where the work is. All right, so let's dissect this part a little bit. This is a question involving either permutations or combinations, which we discussed in class. So let's see if we can figure that out. The reason we know it's either combinations or permutations is because we're choosing 6 out of a bigger set of numbers. We're not just arranging 6 numbers. We are choosing them out of a set of 26. And then, in fact, we do not have to arrange them. They're telling us here that order is not important. It does not matter. All right, so that right there tells us it is a combinations question, not a permutations question. All right, and the reason we know we even have factorials at all is because there are no repeats. We can't choose the same number twice. It's not an exponent question where it's the same pool of numbers you can choose from. Once you choose a number, say you choose the number 5 to use first, that's it. You can't choose it again. You only have 25 numbers to choose from after that. So here we go. Let's make our line 1, 2, 3, 4, 5, 6. And if you remember from class, the n choose r, and we had a little formula, n factorial over n minus r factorial over r factorial. And where did all this come from? Well, the n factorial, let's start up here, comes from this number 26. We know that we are going to choose 6 numbers, and we have 26 numbers to choose from for that first number. After we've chosen that first number, we have only 25 choices left. After we've chosen the second number, we have 24 choices left, and so on all down the line until we get to 21, and then we stop. All right? The reason this r down here, we have r factorial, so this is our 26 here, and this is our 6 here. We're choosing 6 out of a set of 26. That's where those numbers. Now, why do we divide through by this r? Well, if you remember, it's because these numbers here, this factorial here, is taking into consideration, it's counting, for example, if you choose the number 5 first and then the number 2 second, it's going to count that as one way. But then if you choose the number 2 followed by the number 5, it's going to count that as another way. But we don't want that to count twice because we're told order doesn't matter. If you choose a 5 and a 2, it doesn't matter when you choose them. It just counts as one choice. So that's why we have to divide through all of this by the 6 factorial. Okay. All right. So this is going to be a strange thing to type into our calculator. So where does the n factorial, n minus r factorial come from? Well, let's think about it. We know that 26 factorial is actually 26 times 25, 24, 23 times 22 times 21 times 20 times 19 times 18, all the way down to times 1. That's the true 26 factorial, right? But we don't want all this. We don't want all this. So, but what if I divided through by 20 factorial? 20 times 19 times 18, all the way down to times 1. You can see that they would actually just cancel right out. So I'm going to put the 26 factorial in the numerator, and then in the denominator I'll just put that 20 factorial, and that allows for the canceling out. And then I have everything that I want. In the end, I have 26 factorial in the numerator divided by 20 factorial times 6 factorial in the denominator. And there you go. That's your 26. Choose 6. All right. So I go through all of this to explain how this works, how the combinations work, and where it comes from, because it makes more sense that way. But in fact, way back here, once you realize you have a combinations question, you can go straight to your calculator. Once you know it's 26, choose 6. You don't have to go through all of this work. You don't even have to do this. You just have to go straight to your calculator. You are going to, so on your calculator, you will actually punch in the number 26. Then you'll hit your probability button and scroll down till you choose the button that says NCR. You'll see you have 3 choices there, the factorial button and the NPR, but you want the NCR. Enter and then come out and hit the 6, and then you hit your enter button. And this will pop up 203. Oh, I'm sorry. Take back that. 230. 230. There are 230,230 ways that you can choose 6 numbers here out of a set of 26. All right, so we have just found the bottom number of our fraction. So I'm going way back up, back to my yellow pen, and go back to our original problem. The probability of actually winning the lottery in this case is the number of successes. There's only one winning lottery number out of the total possible outcomes, which is 230,230. So that's how a combinations problem works.